Okay, so this video is on dividing polynomials using long division. Now, one thing I want you to notice before we begin, the reason why we are using long division is because of this 4x. Remember, so this is your what we call the dividend, and this is what we call the divisor. So you only need to use long division, though you can use long division for any dividing problem. You should only use long division if your leading coefficient is not 1. So if this was just x plus 1, you could use synthetic division. But because there's a 4 here, and if it was any other number, 2, 7, negative 25, whatever, you would need to use long division. So where you're looking at this number here, if it's not 1, you need to use long division. Now before we begin, I'm going to show you or remind you how you did long division back in grade school, because the process is essentially the same. So we'll make up some problem, it could be anything. So we'll just do maybe 7 divided into 345, whatever. I just made it up. Okay, and what you did is you said, okay, well, I figure out, so 7 does not go into 3, but can it go into 34? And the answer is yes, 7 goes into 34. So 7 goes into 34. Let's see, that's almost 4 times. 4 times 7 is 28, and then you subtract. So 4 times 7 was 28, but when you do long division, you didn't have to subtract those. And that gives me 6. And then you bring down the next number, which is 5. And then you repeat the process. Now, what does 7 go into 65? So 7 goes into 65 9 times. 9 times 7 is 63. And I subtract it. And then whatever I'm left with, there's no more numbers anymore. So whatever I'm left with is called the remainder. So you would have 49 and a remainder of 2. But really, what that remainder means is it's 2/7. So you write this, if you're in grade school, you wrote this as 49. Some of you may have written it as R2, like remainder of 2. But what it really means is that it just couldn't quite make another 7. So it was a remainder of 2 out of 7. So it's 49 and 2/7, which is what that means. So that is the old way you did long division. You kept going, what goes into this, what goes into this, and you kept working your way down until you ran out of numbers, and whatever you were left with was called your remainder. And you put it over whatever it was you were dividing by in the first place. So now, fast forward a few years, and we return to long division, but we involve variables. So I'm going to erase all this. See if I can get a bigger eraser here. Oh, I think this will just be just fine. Okay. Doesn't erase like Notability does, so I gotta erase every single thing on here. Sorry for those OCD people if you see any black lines still. Okay, so let's try this now using long division here. So it makes this a little bit longer here. So we'll start off with the problem. You put what your divisor is or what you're dividing by on the outside. And then you put your division sign. It's going to be a little bit longer here. So 4x to the third, that is 4x to the third, plus 13x squared, plus 27x, and then plus 6. So essentially, you're going to go through and do the same thing. But here's the sort of kicker. You're only actually going to be concerned with this first term here. So I'm going to underline it just so you know. And let's make this a little bit thicker. Okay. And we're only concerned with this number here. So every time you do this, you're going to say, okay, what, how many 4x's go into this? Or, so the easiest way to think about this is when you look at the 4x, the first term here is 4x to the third. Ask yourself, what do I need to multiply this by to get it to be 4x to the third? Now, it's already 4x. So what would I need to multiply by to get it to 4x to the third? And if you said, well, just multiply it by x squared, because 4x times x squared is 4x to the third. And you'd be right. So it is x squared. That's what you would multiply it by. So we put it over the respective exponent here, so x squared. Because when I take x squared and I multiply it by 4x, I get 4x to the third. And now when doing this, we can't forget that we also have to take the x squared and multiply it by the first term, or the second term as well. So we have x squared times 4x is 4x to the third. X squared times 1 would be 1x squared. Now, we have to remember that when we are doing this, just like in regular long division, you have to subtract. Now, since both of these are positive, they're both going to become subtraction. So this will actually become subtraction. And then we subtract down. Now, the 4x to the third and the negative 4x will actually cancel. And then we're left with 13x squared minus 1x squared, which is 12x squared. And then we repeat the process again. So just looking at this first term up here, okay, maybe more obvious here. Looking at this first term here, how many 4x's go into 12x squared? Or another way of thinking it, how can I get 4x to be 12x squared? Now you might have guessed that it's 3x. Because 3x times 4x is 12x squared, that works. So I'm going to put it over its respective thing here, so 3x. And just like we did before, I'm going to multiply to both terms. 3x times 4x is 12x squared. Now that was the whole purpose, was to get rid of this. And oops, I forgot to bring down the 27x, so plus 27x. And then do the 3x times the 1, which is 3x, so plus 3x. Okay, now we do have to remember that, again, that it is subtraction, so these should cancel. So if you ever forget, that this first term should cancel out. That was the whole purpose of it. So if you're like, wait a minute, it's not canceling. Oh, wait, I forgot to do subtraction. And don't forget that the second one is also subtraction, so I do have to change that too. So then I draw my line, subtract everything. Yes, these will cancel just like they did in the first time we did this. And 27x minus 3x is 24x. Now we have one more. I'm going to sort of zoom out here so we have a little bit of room. Let's not do that. Okay. Let's see if we can zoom out the whole paper here. Nope, it's not letting me. Okay, so it's not letting me do that. So anyway, there we go. So anyways, I'm going to bring down the 6x, so plus 6. Okay, and now repeat the process for the last time here and ask myself, okay, so now I'm looking at this 4x over here and saying, okay, how do I get it to be 24x? So, because I need the 24x to cancel, what is 4x times what gets me to 24x? And that should be 6. So plus 6, because 6 times 4x, and I'll do that, 6 times 4x is 24x. 24x. Okay, that's a 4. 24x. And 6 times 1 is 6. Okay, so I do have to subtract, so that changes to subtraction. This also changes to subtraction. And when I subtract these, 24x's will cancel. And actually, 6 minus 6 is 0. So in this particular case, I do not have a remainder. So simply, this is my answer right up here. And I'll just rewrite it down here. X squared plus 3x plus 6. That is my answer. Now, if for some reason I had a remainder, like, it was like 6 minus 2 or something like that. So I had a remainder. If I end up with a number down here, then I would have to add in the remainder. So let's take, for example, that it was like 6 minus 2. So I had a remainder of 4. I would have an answer of x squared plus 3x plus 6 plus a remainder, and this is just hypothetical, it would be plus the remainder of 4 over whatever it was you were dividing by, so 4x plus 1. And that would go right there. Okay. And that's long division. Please, if you have any questions, ask. It's definitely a hard concept. It's not used very often, so you won't see it very often in this class. Synthetic division, as you will see, has many more uses than long division, so we end up using synthetic division a lot more. So if it's confusing, it's one of those things. It's going to be confusing for some. So please don't hesitate to ask questions if you need any help with this. Thanks.